Good morning, friends. Today we are going to discuss about the molding sand properties and testing, which is very relevant to the casting process, because casting process, a good part of it is done by sand casting, and those sands property, the property of those related sands has to be taken care of in order to attain the better quality of the casting product. So, molding sand has a very important role to play. So, we have to know what are the characteristics of those molding sand, how to measure those things, and how it is relevant for the appropriate casting, specifically related to sand casting. So, molding sand properties, there are many. We need first of all the strength, because it has to retain its shape, and even after, when the molten metal will be poured into that, and with maybe a little bit of extra turbulence of those molten metal, they should not jeopardize the intricate part of those molding sand. So, intricate cavities are made in the molding sand by the pattern, and that has to be retained unless the entire part of molten metal solidifies. So, that strength is crucial. If that is not made, then the problem is that defective casting will come out of it. The strength is important for those molding sand in order to retain its shape, very specifically for intricate part of it, which is generated through the intimate contact with the pattern, and then pattern is removed, so that the sand has to retain these difficult shapes and complex shapes even after the molten metal pouring. And if not strong enough, the molten metal will just have detrimental effect in terms of the retention of those shapes made in molding sand. So, strength is important. And what is strength? The ability of the sand mold to hold its geometric shape, because casting is to generate geometric shape through the fluid molten metal and after that subsequent solidification. So, geometric shape is important, and that has to be retained, otherwise the purpose is lost under the conditions of mechanical stress. Who will exert the mechanical stress? The molten metal will exert the mechanical stress, and even after that stress, the sand has to retain its shape, and for that thing it has to possess some strength. The next one is also important, that is ability of a sand mold to permit the escape of gases and steam during the casting process. The gases trapped inside, and they will be liberated, and while liberated after casting, they will make a mark and they will jeopardize the surface finish and sometimes the quality of the casting inside. So, the best strategy is that we have to give the appropriate escape route, and that escape route who will provide that? The permeability, that character of those molding sand will have the good reliable escape route. Permeable means permit, and what permit? The escape of the gases and steam. And how the gases come out of it? Because some organic chemicals will be acting as a binder related to all those molding sand, and these binders are responsible for in order to impart those complex shapes and retaining its strength. But the binding material may be say molasses or other kind of organic and inorganic material will have, at elevated temperature, they will be converted to gas, and once they will convert to gas, they need some escape route. And how the steam comes? Steam comes from the moisture present in the sand in different form, and because of the enormous heat of the molting metal, say the melting point temperature of the steel may be say 1535 degrees Celsius, when molten steel and other part of it pour into those cavities. So in the vicinity, the present moisture will be instantaneously converted to steam, and that steam in the form of bubbles and other part of it needs some escape route. If the mold is permeable, they have very good escape route, then quality of the casting will be retained. But if it is not, it will be present there itself and prepare a permanent mark, and that will be, the casting will be defective because of those presence. The moisture content, that also has to be appropriately monitored. Moisture content affects a mold's strength and permeability. A mold with too little moisture may break. Mold with too much moisture can cause steam bubbles to be entrapped. So it is a conflicting goal. So one has to one has to balance between the dry part of it and very much moistened part of it. So it should be a compromise between these two properties because of obvious reasons. We need the moisture content in order to maintain the strength, the sustainability of those shapes, but the extra, that the formation of those steams entrapped in the casting, and they will create those blowholes. So, and only expert, judicious combination of those sand and the moistened state or the water vapor and all those things has to be done in order to ensure good quality casting. Next is the flowability, the capacity of the sand to fill small cavities in the pattern. We are doing casting in order to generate the different kind of complex and complicated shapes, and in order to sand has to flow through the nook and corner of the intricate part of the pattern that is required, because pattern will be removed and those nook and corner created by those patterns in terms of its conjugate profile will be retained, and they will be mainly responsible for generation of all those critical geometrical shapes. And in order to ensure that the sand is appropriately distributed into the very complex, complicated profiles of the pattern, one needs some flowability. If the flowability is not that, because of the moulding and ramming, the sand particles will not be spread across the surface of all those patterns, and if there is no sand in those intricate parts of the pattern adhered to its surface, the problem is that the formation of those curvatures and shape will not be generated. So everywhere in that is thin layer, whatever the form design part of it, we have to ensure there will be sand, and that sand will only possible if we can provide appropriate flowability into those sand, and with the ramming and other kind of activity, the sand will spread across the different complex profile of the pattern, and in such a fashion retain its strength. Whenever the pattern is withdrawn, those kind of intricate shapes are maintained. So flowability also has to be ensured. In case of sand, flowability is not there, then a lot of effort has to be carried out in order to spread across an appropriate formation of the mold. Then grain size, the size of the individual particles of the sand, and that is also important. Bigger grain size, the packing and other things will be less. Smaller grain size, the bonding and adhesion will be less. So on again, you has to use some kind of judicious combinations of the size and shape. Shape also has a property, but it is not at all easy in order to generate the different uniform shape required for those casting process. So the property evaluates, this grain shape evaluates the shape of the individual grains of sand based on how round they are, and generally 3 grain categories are used in formal sands, and all those the different geometrical properties, and on the basis of that we ensure the correct behavior pattern and characteristics of those sand. So, grain shape is also a responsible factor, but the problem is that to generate a typical homogeneous pattern of the grain shapes and other things other than the spherical are not at all a very easy option. So, one has to find it out how we can have some impact on the grain shape, because in grain shape and other things not at all an easy parameter to control. So, these are three shapes associated with moulding sand. One is rounded grain, typical spherical structures. Another one is angular one, that with the sharp edges are there, sharp corners, and subangular one where the middle road they possess the better strength and lower permeability. And because of these properties and their combination, the flowability, permeability, all those things are obtained associated with those kind of properties of those grains. So, angular grains have some other properties, rounded grains have some other properties, but subangular grains and other things, those things where the permeability and lower permeability and other things is possible. So, one has to critically examine the physical characteristics of those grains if at all possible, but beyond some range it is not at all a very easy option to control those percentage of grains with some kind of features what are not intended for right kind of casting. So, collapsibility, another property, another difficult property, because the strength where it is maintained, we also want collapsibility. Collapsibility is the opposite part of the retention of the strength. Collapsibility means that whenever the job of casting is over, then with just hammering of say mallets or other kind of things, those sand molds has to be broken, so that the core patterns and other things can be retrieved. The full pattern has to be retrieved from the flask of those sand, and that is only possible where it can be collapsed very, very easily. So, collapsibility is the ability of the sand mixture to collapse under force. So, appropriate force will be given so that material, the sand is collapsed and the product is open in order to grab that. So, greater mold collapsibility allows the metal casting to shrink freely as it solidifies with the risk of hot tearing and other things related to those typical casting defects. So, more collapsibility allows it to shrink appropriately without having some kind of directional components. So, the strength of those things are better, otherwise the risk of hot tearing and cracking will take place. So, though in some cases the use of those conventional methodology and other things will be there, but it is better to use the appropriate collapsibility of moulding sand, then and then only we can get quickly the ultimate product. So, these kind of feature also required, but sometimes collapsibility and the strength and other things contradict in terms of implementation. And refractory strength, refractory properties are also very relevant, because we are choosing moulding sand. The reason is that it will retain its shape and it will not be composition will not be jeopardized at elevated temperature. Sometimes we have to keep elevated temperature 100 degree above than the melting point, and that can be for the steel and other things 1635 or above that. So, whenever we are dealing with these kind of temperature, the shape, size and the formation of all those particles near a side which are responsible for giving the different color of shapes, that will be in problem. So, the refractory strain means retain its hardness and shape even at elevated temperature. So, mold must not melt, burn or crack as the molten metal is poured in, and molten metal is of a very high temperature. So, it is not an easy temperature, it is a difficult temperature to negotiate with, and the refractory strength is more ensured in order to have those proper quality casting coming out of those casting process. Refractory strength measures the ability of the moulding sand to withstand extreme heat. In many of the casting is a thermal process. So, where we are using lot of heat, and if the the properties changes with the aid of heat, then the entire exercise of the sand casting and other things will be defeated. So, one has to be very cautious about the refractory strength, that means retains its hardness and shape at elevated temperature, is maintained appropriately so that we can come out with good casting. So, another one, reusability, that is in an eco-friendly atmosphere we definitely want the different characteristics and other things has to be reusable, so that you over and over again we can use, so that it is less hazardous to the environment and also very relevant for the economic applications. So, reusability is a very important thing which is needed also for the moulding sand. And there are various testing procedure. It is not a verbal one that it is good or bad and other things. We need some scientific instrument in order to test those things. So, moulding sand after it is prepared should be properly tested to observe that the required properties are achieved or not. So, required properties has to be achieved from those moulding sands, and we will guarantee that. That will be guaranteed by some kind of special purpose device which will measure all those properties of the sand. And the tests are conducted on a sample of the standard sand. Standard sand will be taken, so it is not a bias in terms of doing for all those experimentation. And the moulding sand should be prepared exactly it is done in the shop floor of standard equipment, and then carefully in closed container to safeguard its moisture content. So, moisture content and all those things is a nightmare for the casting people, and it will make sometimes very difficult for going for the casting. So, here also the standard equipment and other things are there which are carefully enclosed in a obtainer to safeguard its moisture content, because moisture content will jeopardize the many of the casting activity, and preciseness and the quality casting will not be obtained from those casting process where sand options are not added in case of manufacturing of these cast of this product. So, methods of sand testing indicate that the moulding and the performance had helped found remain in controlling the properties. So, these are the tests, and these tests will signify these are the properties of the existing sand, and the testing controls of the moulding sand properties to the control of its composition. The composition has to be controlled, and also baking up another kind of part of it, that also has to be controlled, but main control of its composition. Main control of its composition, and if the composition is proper, we can come out with good quality sand. So, various tests, various exhaustive tests are there, and that will certify just what is the quality of the sand and in terms of their specific property. One is moisture content test, we have already discussed about the clay content test, where with the silt values and all those things in the microform, whether present it or not, the grain that is also full of nutrient. In many of the cases, the plants they require nutrient from the ground. So, we need some kind of clay can be source of some nutrient. The grain fitness test, how the grains and other things are of the same variety, uniform variety, that has to be tested. The permeability test also associated, that how much air and other things escape here, how fast it can come out of it, and so you can permit all those air and other things, that is the degree which we can permit, that is called permeability test. And the strength test also retains its shapes and sizes, because sand is a loose material, so appropriate binders and other things with ramming and some type of cottage industry type we are doing it, so that the permeable can be tested easily. Then the strength test, we have discussed about that. There are few methods where you can test the strength of those moulding sand produced items, and that is also important. So, strength test that can be done by typical type of devices, and through which you can find it out what is actually the properties of these sand in terms of straightness. Then refractory index, so we have to use all those materials even at elevated temperature, they will not go out of their mind, and their teachers, and they should be very cautious about those kind of development and strength is maintained at the last part of the casting also, otherwise it will be a defective casting. Then refractoriness and mold hardness test, they have also their own methodologies to go for that. Moisture content is easy, so whatever the moisture is there, we have to take some standard weight associated, and then we just dry up, and then we again take the weight. Then the difference will be the moisture content. Low moisture content in the molding sand does not develop strength properties. You need strength from the moisture content, but high moisture content decreases permeability, so the gases and other things cannot escape. So life is a compromise. We have to combine those kind of two things in order to achieve, for very specific purpose, the best casting. So 20 to 50 grams of prepared sand is placed in the path and heated by an infrared heating bulb for 2 to 3 minutes. The moisture is the molding sand is thus evaporated, and molding sand is taken out of the pan and reweighed. And all those things associated with that has to be covered in order to carry on those moisture content tests. So molding sand is taken out of the pan and reweighed, and because of the weight difference one can find it out, that amount of water is there, so that amount of moisture is there, and that moisture is possibility of those steam formation will be there. And on the basis of these things, the moisture content can be assessed in a tangible way. So calculation is that before at the green state you weigh, after that dry state one can weigh, and then divided by again the W1, that is the green state, and according to that one can find it out that what will be the calculation behind those typical test of the moisture contents and other part. So in the clay contest influences strength, permeability, other molding. So clay and porosity sometimes contradict in each other, so one has to find it out how much of clay will be there, clay content, and it is responsible for bonding and particles together. It will increase the strength, but at the expense of that the escape of those roots and of the gases will be blocked to some extent. So small quantity prepared, then 50 gram of dry molding sand transferred with a bottle, and 40, all are standards, 475 cc of distilled water and 25 cc of 3% sodium hydroxide, and all those constituent will be there, so that to take away the entire water associated, and then we can write it down that what kind of constituents have what kind of properties. Agitate after that waters and other things, we agitate for 10 minutes with the help of a sand stirrer, and the wash bottle with the water are for the maker. And after the sand has settled for about 10 minutes, siphon the water from and dry the settle down, and the clay content can be determined from the difference of the weights. That is very important. The one clay is just removed and of some artificial methods, and then we can compare with clay and without clay, and with some small steady calculations we can come out with some numerical values. So W1 minus W2 by W1, the similar where whatever in the previous cases we have discussed, and where W1 is the weight of the sand before drying, W2 weight of the sand after drying, and on the basis we will find it out that what will be the value. So percentage clay content will be determined by this formula, W1 minus W2 divided by W1 into 100%, that is 100, that will be the percentage. And Y1 weight for the sand before drying, after drying, so W1 their suffix is taken care of in this very fashion. The another one is the grain size distribution tests and all those things determined with the help of fitness testing and molding sands. An appropriate consist of number of standard of sieves. Sieves another part of it through which the different sizes of sand can go through and come out of it. So sieve numbers and other things are also relevant for grain fitness tests. So shaker vibrates with the sieves, and the sand placed on the top of the sieves screened down and collects on different sieves depending upon their various size. So it is an iterative process, and that way we can get a very good quality of casting where the dimensional distorted size and other things are eliminated. So between sieves are placed in order the fineness from top to bottom. Top will be very hard and blunt, and if you go for the multiple those drones and sieve in terms of elimination of the algorithm, then we can come out with the right kind of product at the end of the last container with those meshes. So, grain fitness test is also another standardized test. Sample of dry sand placed in the upper sieve, and then sand is vibrated for definite period, and the amount of same retained on each sieve is weighted, and percentage distribution grain is completed. So, how it is distributed, another part of it we can calculate with some simple straightforward process. And the quantity of air, another property, permeability test, quantity of air that will pass through standard specification is important, otherwise it will escape, it will just make it mark in different parts of the casting, which is not at all an intended one. And permeability test, an inverted bell jar floats with water specimen tube for the purpose of holding nanometers and measures the air pressure, and those things are just pushed through the air, 2000 cc volume held in the bell jar and entering to the specimen equal to the air escaped. Take the pressure reading of the nanometer and note that time required for 2000 cc another part of air pass the sand and calculate the permeability. So, this is a very standard procedure of calculating the permeability. Permeability has a very big role to play in terms of those casting products. So, that has come out with some standard formula with some number with N is equal to V into H divided by A into P into T, where V is volume of air, H is height of the specimen, A is the area of specimen, P air pressure and time taken by the air to pass through the sand. So, that is known as T. So, measurement of the strength modeling sands can be carried out on universal strength machines, and all those things you can find it out that what strength it can retain, and on the specimen also those kind of activity is to be carried out. So, green compression stand is simply green sand refers to the stress required to rupture and sand specimen under the compressive loading. So, there we are using green composite sands, and the specimen is taken out of those nitty-gritty. I am not going into much of that, and on the basis of that the green compression strength is determined. So, that is also some formula associated with that. They apply hydraulic pressure and rotating wheel, and those things are held between those components, and the green compression strength are calculated. So, green shear strength also a similar manner, only thing is that the adapter is difficult and the universal machine for the loading we made for shearing. Refractory test, that it is used to measure the ability of the sand to withstand high temperature. I have already told that these property is important to retain its shape and size even at elevated temperature when come to the vicinity of the liquid molten metal. So, it procedures also standard procedures, cylindrical specimen and then heating all those things, observe the changes and temperature, and on the basis of that the conclusion will be arrived. So, mold hardness, because we have to measure the strength. So, mold hardness of the mold can be tested, consists of the indicator spring loaded spherical indenter, and on the basis of that it is tested. So, there are also typical value of the AP is applied force, the diameter of the indentation, and if you can get all those values from there itself, you can make a scale where we can compare the different strength, and it is also important for maintenance of the quality for sand casting. So, these are the typical molding sand in terms of a graphical pictorial representation. Green sand full of moisture, dry sand no moisture or little moisture, parting sand when the cope and drag has to be segregated, it is better to put some parting sand so that it can be easily identified and the casting pattern cavity will be in proper shape. The baking sands, so they have their utility coat sands and other things which is responsible for creating the hollow sections, then loam sands and facing sands, and they have their own typical applications. So, there are many, and that is our today's topic of discussion. And to recapitulate that, we have discussed about extensively the different properties of molding sand which is responsible for production of good casting, and there are some standard procedures in order to measure the class of those sands, and depending on the situation we will utilize those sands to ensure those kind of properties which are absolutely important for making a good quality casting on sustainable basis. And then we have seen the pictorial representation of the classifications of the sand, because different sands have different properties, and we have to know that in order to arrive at good quality casting process. Thank you.